Welcome back to our calculus video series. And here I noticed in class today, as we were learning how to take derivatives of various trig functions, sine, cosine, and tangent. And as we were working those problems, realized a quick review of some trig properties that come up over and over in calculus would really help you complete your homework a lot more efficiently. So the first thing I'm going to look at here is just kind of reviewing how we get the sine and cosine and tangent of our special angles here. And just to remind you, I got a unit circle here. And this is how I remember things. You know, I'm always just drawing a triangle in this circle. And this is where sine and cosine comes from. You know, you might draw a triangle in here. And this triangle, it's a right triangle. Okay, we call the angle theta. That's supposed to be a theta, as is this. And not an eyeball, but a theta as it goes, you know, a 0-degree angle is the x-axis. A 90-degree angle is, you know, pointing up to the y-axis. And 180 is going out the negative x-axis, and so on. Notice the y side of this, this is a unit circle, meaning the radius is 1. This is the y side of the y side of the triangle is the sine of theta. The x side is the x distance is equal to the cosine of theta. So you might even look at this point right here. On the unit circle would be cosine of theta, comma sine of theta. Okay, we know what? We know x squared plus y squared equals 1, so we know this is a true identity. The cosine squared of theta. So this is a popular plus sine squared of theta is equal to 1. Okay, so how do we get our angles? Now remember, x is the cosine, y is the sine. When we have theta equals 0, I'm just going to draw a bunch of triangles, and this is how I remember things too. A triangle, if my triangle is basically this, you know, it has no theta is equal to 0, well, y is 0, so the sine is 0. The cosine is 1. And then the tangent, well, what is the tangent? The tangent is going to be the slope of this line. The tangent is the slope of that line. Okay, the slope of that line is going to be y over x, which is the sine of theta, over the cosine of theta, which is the tangent of theta. Okay, the slope of this line when it's 0 is sine over cosine over 0. Okay, let's draw the 30-degree then. Okay, a 30-degree angle. 30-degree angle is like what I call a skinny angle. And I know one of these sides. This is what? This is 30 degrees, or that's pi over 6. 30 degrees or pi over 6 right here. The small side is a half, and the long side, so that's a half. The small side, the long side is square root of 3 over 2. I do have to remember things, and remember, square root of 3 over 2 squared plus 1 half squared has to be equal to 1. But now what's the sine? Well, the sine is the y, so sine of, oops, and I put these in the wrong place, didn't I? That's 0, 1, 0. Make my table correctly. At pi over 6, or 30 degrees, I got the sine is 1/2. The cosine is root 3 over 2. And well, then what does that make the tangent? Well, the tangent is sine over cosine, so it's going to be 1 over root 3, and that is going to be equal square root of 3 over 3. Hopefully you can read that and play this slowly. Okay, that's 30 degrees. What about 45 degrees? Well, 45 degrees, remember x and y are the same. Struggling with my drawing today. That's pi over 4. That's equal to what? That's 45 degrees. And now I know x and y are the same, and I happen to know, well, you can even solve for that. That's square root of 2 over 2. What's the slope going to be? Well, if x and y are the same, the slope is 1. Pi over 4, the cosine's root 2 over 2. The sine is root 2 over 2. Okay, what about, well, let's draw some more triangles. What about pi over, I call this the fat angle. This is what? This is pi over 3. Or that's 60 degrees. Now the small angle is a half. The small side's a half. The long side's square root of 3 over 2. Well, what's the small side? Well, it's over here. If you do a little drawing, it's kind of obvious. That's the small side. The large side is root 3 over 2. Okay? Well, you can see the y side is root 3 over 2. So this is root 3 over 2, root 3 over 2. The cosine is 1/2, and then the tangent is the slope. The slope's a little bigger here, the slope's a little steeper, and this is going to be root 3. It's going to be sine over cosine. Well, what about pi over 2? Well, here's pi over 2, okay? There is no x, it's all y. So since there's no x, the cosine is 0, sine is 1. Well, what's the slope of this line? What's the slope of that line? Well, it's undetermined. Indeterminate or undefined, but undefined. Okay, and we're back, and we derived kind of this table of what the sine is, what the cosine is. What's the sine, what's the cosine, and what's the tangent for our special angles of 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And you have to know these. You can't like scratch your head when I say the cosine of 0. You need to know that's 1. You need to know the sine of pi over 2 is 1, or it's going to take too long to answer some questions. Now, this is all these angles are first quadrant, right? First quadrant. This is the first quadrant, and we know sine, cosine, and tangent are positive. What about the second quadrant? What if I'm over here in quadrant 2? And let's say I got an angle over here, and let's just do one of them. And let's say this angle here, that looks a little bit skinny. Let's call that angle is pi over 6 here. Which means what? That means this angle must be 5 pi over 6. Because you have to know, well, of course, that's pi, right? Down here is 3 pi over 2, and this is 2 pi. And this is pi over 2. Okay, so what's 5 pi over 6? Well, you need to see that triangle again. I would draw the triangle, and it's over here, and this is pi over 6. So remember, it's not going to change. The skinny side is 1/2. Well, that's 1/2. The long side is root 3 over 2. But notice x is negative over here. That's a negative root 3 over 2. So if I made an angle, if I filled in this angle over here, and I called it 5 pi over 6, you'd have to recognize, well, let's see, the sine is a positive 1/2, but the cosine is negative root 3 over 2. And then, well, if it's sine over cosine, this would mean the tangent is minus 1 over 3, or it's equal minus root 3 over 3. And again, this would be this slope, right? The tangent here is that slope. That's certainly a negative slope up in that angle, up in that quadrant. And so you have to understand if x, and you can figure out all these things. I mean, we could pick one out down here. Let's draw an angle down here where this is what? Pi over 3. Pi over 3, right? So what would you say in this case? Well, I'm going to draw that angle down here. Right? The true angle let's see, which side is 1/2? Well, that's a 1/2 right over here. The skinny side is a half. The long side is √3 over 2. But notice x is negative, but y is negative too. So if I put this thing down here, let's see if I can grab that. It's not letting me move it. Well, what is this angle here? This angle, oh, I gotta get my pen back. Let's go back here. I lost that thing. This angle, I move things, is what? That's going to be pi plus, that angle is going to be 4 pi over 3. It's a third pi past pi. So if I looked at 4 pi over 3, I would say what? What's the sign? Well, oh, sorry, the sine is minus 1/2. The cosine is the x value minus 1/2, right? X equals that. Y is equal to minus √3 over 2. Well, what's the tangent? The tangent's just going to be the sine over the cosine, and it's going to be √3, the slope of the line. Okay, so you could walk around this unit circle and you can derive what sine, cosine, and tangent are, okay? And again, you got to be able to plot these functions as a function of theta, as we talked about earlier in the year. In doing calculus, you might be forced to solve this particular trig equation. Solve trig equation. I want to remind you that there's two angle x's that would solve this, right? If I would look at where the cosine is 1/2, it's negative. I got this angle here, right? And that is what? Well, this is pi over 3, so this is 2 pi over 3. And then I could have this angle too, or 4 pi over 3. Remember, x, a cosine is the x value, so for both these angles have an x. Maybe I should make this theta not to confuse you. That's theta. Call this x is equal to minus 1/2. So there's two answers for this theta. Theta could be 2 pi over 3, or theta could be 4 pi over 3. And actually, you can also flip it around. You could flip it around many times around the unit circle too. So you could actually have these two kind of angles to solve this. And this all comes back from our table over here, right? We had 4 pi over 3. From theta equal 4 pi over 3, the cosine's minus 1/2. If we put 2 pi over 3, we would have got cosine was 1/2 too. Okay? Okay, so you might encounter something like that. What are some of the other trig things you need to know? Well, again, we're going to study the let's get let's get a different pen. I know we're getting a little long here, but I want to get this on one video. We want the cosine of x. Let's take the cosine of x. Let's take the sine of x. Let's take the tangent of x. Okay, I want to know, well, the derivative of the cosine of x with respect to x is equal to the negative sine of x, so a little calculus there. I want to take the derivative of the sine of x with respect to x. That's equal to the cosine of x. And we can derive the sine of x as the tangent of x is equal to the sine of x over the cosine of x. And with that, you could then derive the derivative of the tangent of x with respect to x is equal to the secant squared. What else do we need to know? Okay, this kind of things came up. We need to know the reciprocal functions. Reciprocal functions, and we'd say, well, the secant of x is equal to 1 over the cosine. You could derive the derivative. I'm not going to do that here. The cosecant of x is then equal to 1 over the sine. And then the cotangent of x is equal to 1 over the tangent of x. Okay? All right, very good. What are some other, we're at 15 minutes, other things that come up all the time? Okay, you do need to know these identities. And there's a ton of trig identities, I know. But let's just do two right here. We're going to do the cosine squared of x plus the sine squared of x is equal to 1. And then let's these other ones, maybe the sine of the one double angle formula. One double angle formula, the sine of 2x is 2 times the sine of x times the cosine of x. Again, there's a tremendous amount of trig identities. These seem to come up in problems regularly. Okay, 16 minutes. There's your review of trig. Hopefully that helps you a little bit. You can look back in a book, but I think if you remember how to do those triangles around this unit circle, it comes right back to you as far as how to calculate sine and cosine. And again, you need to be able to tell me real quickly in a problem, oh, the cosine of 0 is equal to 1. The sine of pi over 2 is equal to 1. The sine of 0 equals 0. Those got to be like, 10 seconds. You can't be thinking too long on that. All right, see you soon. Bye-bye.